Okay, hi guys. For tonight's video, you need your calculator and you need this note sheet that I passed out in class today. We are going to take a look at linear versus exponential regressions on the calculator and determine for a set of data which would be a better choice, a linear model or an exponential model. And regression just means the line of best fit, or in the case of an exponential one, the curve of best fit. So real quick, I wanted to review the characteristics of a linear function. Linear is an algebraic sequence, which means has a constant rate of change. As x increases, y increases. So with an algebraic sequence, we are adding to get from one term to the next. And that will give us a linear equation in the form y equals mx plus b. This is what we're starting at, and the slope is what we're adding to get from one term to the next. And clearly, a linear equation will have a straight line when you graph it. An exponential function is a little bit different. It's a geometric sequence. So instead of adding to get from one term to the next, we are multiplying by something we call the common ratio or growth factor. So as x increases, y is multiplied by a constant, and that constant is referred to as the growth factor, and that's what we're using, or the common ratio, the growth factor, that's what we're using for b. So a is the start, that's our y-intercept, and b again is the common ratio, the growth factor. So exponential functions will look like this. This will be an increasing function, which we've been focusing on in class the last few weeks. And next week we'll start looking at decreasing functions. How is that going to affect our growth factor right here? So let's take a look at the next step. Make sure on your calculator you have turned on the correlation coefficient, because we're going to need that to determine if linear or exponential is our best model. So turn your calculator on. To turn on the diagnostics, you're going to go to second and 0 for the catalog. And then for my calculator, I have to click all the way down to diagnostics on. Some of you can use a different function, but this is an older operating system. So diagnostics on is right here. And then I'm just going to hit enter twice. And then done, my diagnostics are on. So we know how to input lists. We hit our stat and then we hit enter. And the data that I have in my calculator is this data right here. It is the table that shows the number of votes cast in the sample U.S. presidential elections between 1840 and 2012. So the T is the years since the first election right here in 1840 that was recorded for this data anyway. And then 172 is how many years it was from 1840. So T is our time since 1840. And then our total votes cast is in this column right here. This is just telling us the election year. We never put in the year numbers, and this is just telling us who the party candidates were. So let's go ahead. I've put these in the calculator already. So let's go ahead and take a look back at the calculator. So I've put all of this data into list 1 and all of this data into list 2. And if you look at list 2, we have this little E6, let me turn that back on. We have E6, E7. The calculator is not big enough, or the screen in this part is not big enough to hold all of these numbers, so it puts it in scientific notation. But if you want to know what that exact value is, just arrow over it and look down here, and it tells us that 2.41 e to the 6 is 2,411,118. In that case, it's voters. So we want to take a look at this data. So I need to make sure my stat plot is on. I want to look at the graph. So I'm going to hit second and y equals. And my stat plot is on. But if it was not, I would just hit enter twice. Make sure it's on a scatter plot. I want to see the graph. So I'm going to hit zoom and 9. And if I look at this, it looks like an exponential model, but I can't say that it looks like an exponential model. I have to prove that it is, and that's why we turn the correlation coefficient on. So let's go back to our calculator directions, which are right here. I've already input the list. You know how to do that. We need to calculate the linear regression. This is where we are right here. I've turned the stat plot on. I've looked at my graph to see if it looks like it's linear or exponential, but I need a little bit more information to do that. So back to my calculator. I'm going to hit stat again, arrow over to calc, and I want the linear regression because I want to see what the R value is. So I'm going to go down to number 4, you're going to have to hit enter several times. I just have to hit it once. And it gives us our slope, which is A, and in this case is 807,117.84. It gives us our y-intercept, which is negative 19,782,670. And this is what we're looking for right here. It's giving us an R value of 0.968, which is a pretty good fit, but we have to see if the exponential regression is a better fit. So to do that, to calculate the exponential regression, we go back to this point right here. We are going to hit Stat again, arrow over to Calc, and this time we want 0. That's going to give us the exponential regression. So you can either click on the number 0 or arrow down to 0. I'm going to click on the number 0, and again I have to hit enter just once. So here is our start, 3,457,873 and 16/10. And the growth factor in this case is 1.022 or 1.023. But this is what I'm looking at. I'm looking at the correlation coefficient. And in this case, this correlation coefficient rounds to 0.986. So let's take a look at that data. I wrote that down so we could take a look at it. That's the data I put in the calculator. And here are the equations for the linear and exponential models. So the linear model gave us a correlation coefficient of 0.968. The exponential model gave us a correlation coefficient of 0.986. So how do we determine which was a better fit? Well, we look at the correlation coefficient, and 0.986 is bigger than 0.968. So this exponential equation, this exponential model, would be a better fit for our data. So you need to know how to turn the diagnostics on and how to put the data in the calculator, and I think we're pretty proficient at that at this point. So your job is to answer the 2 video questions. So using your calculator and your calculator notes, this is a table that shows the digital downloads in the year 2000, 2001, 2002, and 2003, and the customers, and this is in millions. So you need to put this data in your calculator, and again, this number is going to be the years since 2000. So in our X list, this will be represented as 0, as 1, as 2, and as 3. Once you do that, find the linear model and the exponential model and determine, look at the correlation coefficient and see which model is a better fit. Then using that equation, if you determine that it was linear, use the y equals mx plus b. If you determine that it was exponential, use y equals a times b to the x to answer question number 2. If the pattern continues, how many customers will there be in the year 2017? Keep in mind, 2017 is 17 years since 2000, so your x in this case is going to be 17. When you're using your equation, make sure to round to the nearest hundredth. When you round your final answer needs to be rounded to the nearest whole number. Please make sure that you put these answers in the Google form, and if you have any questions, fill out that section of the Google form as well.